Thank you, Simon. Good morning, everyone. So I'm going to present the state of our networks, of our road networks. What we tried to do was to evaluate the practices and techniques in road network management, identify problems, and develop afterwards the deterioration process. Excuse me. The first part was a survey in the departmental level in France. We had 26 responses, which means a quarter of the departments that answered. And then we did a survey of metropolitan area, and there we had a low response rate because they did not yet have a structure to respond like the departments. So what did we look at? We looked at the road network types, whether they had a maintenance policy at the department level, whether they knew the structures of the road pavements and the techniques used, what were the pathologies they encountered and the periods of onset, and solutions for wear and tear, and also to get a feedback and what were their expectations from the project. Then we had complementary topics that first of all, the roundabouts outside the built-up areas, relationship between techniques and network classes, the maintenance life of class 3 and 4 networks. That means smaller networks, about 70% of the roads in the departments, the deteriorations of road pavement structures, and pathologies brought on by climate conditions. What can sue on the typologies, on the 26 answers, we realized that departments have about 4,000 kilometers of road networks, which are broken down in 4 categories. One are the structural routes, the main roads, which represent about 30% of the network, and 3 and 4 are local service roads, which are about 70% of the network. In their maintenance policies, they all have a road database, and the policy is not always the result of defined processes. Works are scheduled usually on a 3-year basis, and is not always codified. On our knowledge of the structures, we don't know our structures until 5. We see that the departments don't know their road pavement structures. There's a caveat here, is that in class 1 and 2, we have 2.7, 2.4. We know about half the structures. For 3 and 4, we're about 2.2, so it's a small average. For class 1, in average percentages, we have about 80% of our roads which are in thick asphalt or in hydraulic materials. However, on class 4, the smaller network, we have 94% with supple, flexible, which will have a treated or untreated with broken stone pavements with hydraulic binders. Now, the pathologies that we see here in class 1, the main networks, we realize that we'll have for the rutting of the wearing course, tearing, peeling, slipperiness. These will appear between 10 to 14 years after, and is often due to traffic or the age. On the cracking at the top of the bituminous mixes, the transverse cracking, joint treatment, and bleeding. This appears after 3 to 8 years, and that's mainly due to the climate and thermal variations. For class 4, it's different. We have the rutting of the wearing course, tearing, peeling, which arrive the cracking at the top, transverse, and as peeling slipperiness at 9 to 10 years, and then we'll have peeling, transverse cracking, and joint treatment, which will appear after 4 to 7 years. And once again, this is due to the climate and heat or thermal conditions. So the deterioration that we see most often in these flexible roadways, we have cracking at the top, alligator cracking, rutting, joint cracking, a bit of bleeding, edge deformation, and transversal cracking. For resurfacing or reinforcement, we asked what was advised. If we have a BBG, a classic BBG, we realize in Alsace Milks we see the renewal of the roadways on the main categories are about 4.5%, let's say 5% on average, a renewal every 20 to 22 years. However, in the class 3, we have very low rates of renewal, 1.6, 1.1, 1.5, let's say average, which means we have the surface we have resurfacing between 63 to 95 years, which is a very long period of time, and we know nothing that can resist that long. For the service life, for maintenance, we wanted to compare what departments expected from each technique and what was their standpoint. The first two on the left is kind of anecdotic. We have pata, crack bridging, etc. The hopeful life cycle is about 6 years, which is in line with the department's expectations. For cold storable bituminous mix, they're not necessarily, so we have we look at we fill some holes, and we have a very low life cycle of one year, maybe a little more. And then we have preparations that are done during the warmer seasons. We see that each technique has about the life cycle that's expected. We take different techniques. For surface dressings, we're looking at 13 years of life cycle. For the cold cast bituminous materials, that's where we have the greatest gap, where we hope for 10 years, and we're at, on average, around 8 years. For cold mixture, for superficial wear, we're in 13 years, which we saw previously. For the cold mixture, we have a small gap, which can be explained that there's very little cold mixture today, less than 5% in France, and so not necessarily with good feedback or good practices. And there'll be a new national project for cold mixtures where we'll explain how to use this material compared to hot mixtures. There's many more specificities. You have to be careful when you put these down. And so I think in a few years we'll correct some of the faults with an increase of these practices for BBUM and BBTM. So VTAS and TAS, we're looking at about 10 years. BBSG, BBME, we're looking at 13, 14 years. And the good surprise is that for the special tars, or asphalts, we have an estimated amount that is lower than the real life cycle of these materials. So this graph here shows you what we saw previously, so it's in percentages. So emulsion techniques is where we have a lowering of 30%, which is for the TAS And once again, for FAS, we see that the life cycle is longer than expected. This shows you the various maintenance techniques for the various networks. We see that hot and warm bituminous mixes are used a great deal in classes 1 and 2. The structural, the longer roads, a little bit in category 3 and very little in category D. However, on the other hand, we see that reprofiling and filling the holes. We have maintenance on the longer roads, structuring roads, and less work on categories 3 and 4, where we have a lot more damage, deterioration, because of the agricultural traffic and heavy-duty vehicles, which aren't really, where these roads aren't really designed to carry that sort of thing. And we have crevices in all of the categories, a little more on categories 3 and 4, because 1 and 2 are often have concrete bases or are well configured to avoid enormous amounts of maintenance. So if we look at the techniques of maintenance, we see we use very little cold coverings, more on surfaces on categories 3 and 4. For superficial, we do it on the 3-4, often to  have a BBSG type to put an MDG or have an additive to the asphalt to avoid water leaks, and then cold vitamin C surface dressings, mixed specific maintenance. Crack bridging we have less in 1 and 2 because we have less of hot coverings on the more important roads. In the complementary study, we asked the departments the number of roundabouts they had, and on average we have about 228 per department, which means one roundabout every 18 kilometers. That's outside urban areas, and these roundabouts 70% for thick bituminous surfaces, 10% that are semi-rigid, often cement-based structures, and then we have flexible coverings, and 6% which are mixed. So here we did the same thing. We looked at the deterioration by the amount of appearances. We see that usually it's a separation of the longitudinal and transversal joints. We have cracking at the top, and then we have fatigue cracking. Then we have surface glazing and or rutting, alligator cracking, and the cracking of cement-treated base courses. The conclusion of the study, therefore, we had a better knowledge of the typologies of the networks and the roadworks and the policies we have on our routes. The network typologies, we see that each technique is different, and it depends on the category of the network, the identification of quantification according to network class and type of pavement structure. There was pathologies that we encountered, the periods of onset, the mechanisms of onset, and aggravating factors, and the service life of road pavement structures or techniques. So the conclusion of the study is the comparison of the expected and actual service lives. We see more or less in what we expect. The behavior and service life of roundabouts outside urban areas or built-up areas, and also what came out in the 26 departments, is that if they have a mountainous road network, which is above 800 meters, would like to create a community to be able to exchange on specific deteriorations because of the specific climatic conditions? Thank you very much.